For centuries, we wondered what was on the surface of Mars. But today, with spacecraft in orbit and rovers moving across its ground, we know more about Mars than any other planet beyond Earth. We've seen vast canyons that once carried water, watched dust storms rise from the horizon, and uncovered signs that life may once have existed there. These were the discoveries we were searching for, and yet, Mars continues to surprise us. Recently, NASA's Perseverance rover detected something completely unexpected, something it wasn't even designed to study, something we had almost stopped looking for. A faint crackle, like a cable being pulled from a speaker, may be the first evidence of lightning on Mars. A phenomenon we had never been able to confirm before, no matter how hard we tried. So why are we only hearing it now? What does it reveal about Mars? And more importantly, what does it mean for the future of human missions on its surface? Today, we turn our attention to Mars to investigate a sound so small it was almost dismissed. A faint crackle that may hold the key to understanding how the Martian atmosphere behaves, how its storms evolve, how its surface chemistry is shaped, and whether humans could one day safely walk there. The first spacecraft to ever land on Mars was NASA's Viking 1 in 1976, followed just months later by its twin, Viking 2. These missions gave us our first close-up color views of the Martian surface, a red-brown world beneath a dusty orange sky. Since then, 8 more landers and rovers have reached the surface. And even now, 2 are still active, Curiosity and Perseverance. Together, these robotic explorers have transformed our understanding of Mars. They revealed a planet that once held liquid water and may still hide vast reserves of it, frozen just beneath the surface. But they've also had to endure an extreme world, blinding sunlight, violent winds, and planet-wide dust storms. And yet, through all of this, one thing was always missing: lightning. We've seen it across the solar system. Voyager 1 captured flashes on Jupiter in 1979. Juno later revealed them in stunning detail, and on Saturn, storms can stretch for thousands of miles, unleashing lightning up to 10,000 times more powerful than on Earth. In 2009, the Cassini spacecraft observed a single storm on Saturn that lasted for 8 continuous months. But on Mars, nothing. No confirmed lightning, not until now. And that changes more than it seems. Because lightning is not just a flash in the sky. It is a force that rewrites atmospheres and reshapes the chemistry of entire planets. On Earth, lightning begins with something simple: interaction. Inside storm cloud, ice particles crash into each other, exchanging electrons and building up powerful electrical charges. As that imbalance grows, the air can no longer contain it, and in an instant, the charge releases as a lightning bolt, heating the surrounding air to nearly 50,000 degrees Fahrenheit. That's hotter than the surface of the sun, and in that brief burst of extreme energy, molecules in the air are torn apart and forced back together into entirely new forms. Nitrogen and oxygen recombine into reactive compounds that fall with rain, feeding the soil below. Lightning doesn't just illuminate the sky. It actively reshapes the chemistry of a planet. It also creates ozone, helping shield the surface from harmful ultraviolet radiation, but its influence may go even deeper. Some scientists believe lightning could have played a role in the origin of life itself, converting simple atmospheric gases into complex organic molecules like RNA and amino acids. In other words, lightning is far more than a flash in the sky. It is a core part of how a planet functions. And if it plays such a powerful role on Earth, it should, in theory, shape Mars as well. But Mars is different. Its atmosphere is more than 100 times thinner than Earth's, lacking the dense clouds and towering storm systems where lightning usually forms. At first glance, that should make lightning almost impossible. But storms are not the only way electricity builds in nature. On Earth, volcanic eruptions can generate lightning too. Inside massive ash clouds, tiny fragments interact. separate charge, and release sudden electrical discharges without any traditional storm clouds at all. And if there is one thing Mars has in abundance, it is dust. Fine, dry, electrically active dust. Martian winds can lift it into towering dust devils reaching nearly 12 miles high. At any given moment, there may be over 100 million of them moving across the surface. Not isolated events, but a constant, planet-wide system. And then there are the storms. Some grow so large they consume the entire planet. The Viking missions saw 2 global dust storms within their first year alone. These storms are driven by seasonal heating, as rising warm air creates continent-sized systems, and every few Martian years, they merge into something even larger. Scientists still don't fully understand why these massive storms appear in cycles, but Mars follows a more elongated orbit than Earth. During southern summer, it moves closer to the Sun, heating the surface more intensely. Winds may only reach around 60 miles per hour, but the dust is so fine, it can block out sunlight across the entire planet. For solar-powered machines, that is catastrophic. In June 2018, a global storm ended the mission of the Opportunity rover. Permanently. But while destructive for our machines, this constant motion of dust creates something else. A system where particles collide, separate charge, and build invisible electric fields across the planet. And for decades, scientists have been searching for one thing that would confirm it. Lightning. For decades, scientists searched for signs of electrical activity on Mars and kept finding nothing. The European Space Agency's Mars Express spent 5 years scanning dust storms for any signal of electricity, but detected none. Another mission, the Schiaparelli module, carried instruments designed specifically for this purpose, but never got the chance to use them. In October 2016, a software error caused its parachute to deploy too early, and the module crashed before reaching the surface. Even its final moments were captured from orbit, a silent reminder of how difficult it is to study Mars directly. And then, after all those years, the evidence didn't come from a mission designed to find lightning. It came by accident. The Perseverance rover, quietly working on the surface, picked up something no one was expecting. Its SuperCam instrument was built to study rocks. It fires a laser, vaporizes tiny portions of the surface, and analyzes the light and sound that return. But hidden within those recordings was something else. A faint, irregular crackle. Not from rock, not from the rover, something different. The signal was so unusual that scientists began to investigate. A research team spent nearly 45 months combing through the data and eventually identified 55 distinct acoustic pops spread across 2 Martian years, and most of them appeared during dust storms or inside dust devils. The pattern was hard to ignore, but was it really lightning? Or something else entirely? In a study published in November 2025, the team systematically tested every alternative explanation. Could the signal have come from the rover itself? Unlikely. It didn't match any known mechanical or electrical noise. Could it be dust striking the microphone? That might explain the sound, but not the accompanying electromagnetic signature. So the team took the next step. If Mars couldn't be tested directly, they would bring Mars to Earth. Recreating the conditions of a Martian dust storm, they set out to see if these tiny discharges could be produced in the lab. To test the idea, the team recreated Mars in the lab. Using a replica of the SuperCam instrument, they rubbed particles together to build up static charge, then recorded the result. What they captured was strikingly similar to what Perseverance had heard on Mars. Not identical, but close enough to point in the same direction. After months of analysis, the conclusion became difficult to avoid. Those 55 faint pops were not random noise. They were best explained as tiny electrical discharges, a form of lightning, scattered across the Martian surface. Not powerful bolts, but countless micro-events happening quietly inside the dust. And then, A second line of evidence appeared. In February 2026, another team examined over a decade of data from NASA's MAVEN spacecraft and found something else. A single, fleeting signal known as a Whistler wave. On Earth, Whistler waves are low-frequency radio signals that travel along magnetic field lines before fading out. But what matters most is their origin. They are created by lightning. Wherever you find them, you are almost certainly looking at electrical discharge. These signals have been detected on planets with strong magnetic fields, Jupiter, Saturn, even Neptune, but never on Mars, until now. Mars doesn't have a global magnetic field. Its internal engine shut down billions of years ago, but fragments remain, localized magnetic regions, scattered across the crust, especially in the southern hemisphere. And under the right conditions, these fields can guide electrical signals through the atmosphere, which raises a deeper possibility. When dust storms generate electrical charge, those signals may travel along these hidden magnetic paths, producing the Whistler waves we can detect from orbit. A planet that seems quiet may still be electrically active beneath the surface. But how often does this really happen? So far, out of more than 100,000 data points, only one Whistler wave has been confirmed, lasting less than half a second, which doesn't mean it is rare. It may simply mean we are only catching brief glimpses of something much larger, a system that is active, but difficult to observe. For MAVEN to detect it, everything has to align perfectly. The right place, the right time, the right conditions, and that almost never happens. But absence of evidence is not evidence of absence. When you combine that single signal with what Perseverance recorded, the picture becomes clearer. Mars is almost certainly producing electrical discharges. But this is not lightning as we know it. Not towering bolts splitting the sky. On Mars, it is closer to static electricity. Like the shock you feel after walking across a carpet. Small, brief, almost invisible, but not rare. Because across the surface, storms and dust devils are constantly forming. There may be millions of these micro-discharges happening every single day. And that changes how we understand Mars entirely, because once dust becomes electrically charged, everything shifts. Charged particles are easier to lift. They stay suspended longer, and they interact differently with each other. This is not just weather anymore. It is a feedback system. The storms create electricity, and that electricity helps sustain the storms, which leads to a deeper mystery. For decades, scientists have known that Mars is filled with highly reactive chemicals, oxidants that aggressively break down organic material, but their origin was never fully explained. Now, there is a missing piece. Even weak electrical discharges carry enough energy to break molecular bonds. On Mars, these countless micro-events may be producing compounds like hydrogen peroxide and perchlorates, chemicals already found across the surface, not in isolated events, but continuously across the entire planet. Which leads to a more unsettling implication. Mars may not just be lifeless, it may be actively hostile to life. These oxidants destroy organic molecules rapidly, erasing chemical traces before we ever have a chance to find them. So even if life once existed there, the surface may no longer remember it, which changes how we search. The surface is no longer the primary target. The real evidence may lie below, buried, protected, hidden from this constant chemical destruction. But the implications do not stop there. This electrical dust doesn't just affect chemistry, it affects machines. When particles become charged, they become sticky. They cling to surfaces, building up layer by layer, like tiny charged beads that refuse to let go. On Mars, this dust can coat instruments, block sensors, and cover solar panels. Over time, it reduces efficiency, and eventually, it can end missions. In December 2022, NASA's InSight lander fell silent after its solar panels became completely covered in dust. Not destroyed by impact, but slowly shut down by the environment itself. The next generation of missions is already on the way. New rovers are being prepared. New landers are being designed, each one more capable than the last. And for the first time, we are approaching a moment where machines may no longer be alone on the Martian surface. Both NASA and private companies are planning to send humans to Mars within the coming decade. Missions to the Moon are already underway, not as a final destination, but as a testing ground, a place to refine the systems that will one day carry us much farther, step by step. We are learning how to survive beyond Earth, how to build habitats, sustain life, and operate in environments that were once completely out of reach. But there are still things the Moon cannot teach us. Mars is one of them, because Mars is not just distant, it is different, and this newly discovered electrical activity is part of that difference. The first humans to walk there are unlikely to face towering bolts of lightning, but that was never the real danger. The real challenge is quieter, harder to see, invisible charges building in the dust, interfering with systems, disrupting instruments, slowly wearing down the technology we depend on. The danger is not a strike from the sky, but the electricity beneath your feet, which means this discovery is more than a scientific curiosity. It is an engineering problem, one we will have to solve before we can truly live and work on another world. And yet, it all began with something almost ignored, a faint crackle, buried in noise, hidden inside data no one was even looking for. We didn't just hear a sound, we uncovered a system, a planet that is not silent, but quietly active, reshaping itself in ways we are only beginning to understand. And if Mars can still surprise us like this, after everything we've already learned, then the real question is not what we've found, it's what we've been missing all along. Thank you for watching. If you found this analysis valuable, consider subscribing for more deep space insights. And as always, stay curious.